All right, so for the next section, we're going to be looking at converting polar coordinates to rectangular coordinates, just like when we learned a new unit of measurement for our angles, like when we converted radians to degrees. It's the same idea. We want to convert back between the units. So if we think about what we did in the unit circle, x was cosine theta, y was sine theta, but now we have r here instead of 1. So our x is going to be r cosine theta, and our y is going to equal r sine theta in terms of how we are going to do our first conversion. And then the other thing we want to think about in terms of figuring out our theta going back the other way, theta is going to be equal to tangent, or tangent of theta is going to be equal to y over x, and then we can use that equation to help us solve. So this is one set of equations that we are going to use for converting. And then the other set is going to be using that tangent theta, and then to figure out the radius, it's Pythagorean theorem, x squared plus y squared is equal to r squared. So we're using the outside parts of the triangle to help us figure out r and theta. And then we are using the kind of inner parts, the angle measurement and the r value, to help us figure out our x and y later on. Okay, so I'm going to move on down to our first section where we're converting polar to rectangular. We have our r, we have our theta. So in order to convert for that, we are going to plug into those specific things. Now the nice part of this is you don't really have to worry about the quadrant, although it is helpful to graph it. So we would go out to circle 4, 1, 2, 3, 4, and then we would go over to 3 pi over 4, which would be smack in the middle here, and that's our first point. So that is in quadrant 2, if we were to graph it. And that's kind of help us kind of see, all right, are we in the right spot when we go to find our final answer. So this would be x equals 4 cosine of 3 pi over 4. Now you do still kind of need to go back and revisit your exact value stuff. So this would be negative root 2 over 2. So what I would do, even if you did use the calculator for this, find cosine of 3 pi over 4 and then multiply that answer by 4. And then same thing, y is equal to 4 sine 3 pi over 4. So you do kind of want to remember your all students take calculus, which things are positive, which are negative. So sine is positive. We would do 4 times root 2 over 2. And we would get our rectangular point of negative 2 root 2 to root 2. And that makes sense. A negative x and a positive y does fall in that second quadrant. So the 2 points match up. All right, the next one, if we were to graph that, we would go out to negative 6. 1, 2, 3, 4, 5, 6. And then we would go pi over 6 in that direction, or in the counterclockwise direction. So that would be our second point. That one is in quadrant 3. So again, we just want to make sure when we plug our information in that we get a point that's in quadrant 3 in the rectangular form. We'll do x equals negative 6 cosine pi over 6. So negative 6 times, and pi over 6 for cosine is root 3 over 2. And then y would be negative 6 sine pi over 6. Negative 6 times 1/2. So they do, in fact, both come out to be negative. We're going to get negative 3 root 3 and negative 3. So again, checking negative x, negative y is correct for the third quadrant. Now, as long as you have your all students take calculus, that should not be a problem. The next one's a little trickier because we have 2 options for our quadrants, so you have to be careful. You have to be careful which one you pick based off of the initial graph. So for this, although I'm not going to graph the polar coordinate right away, what I do want to think about is when I go to graph it, this is negative x, positive y. That's going to end up being in quadrant 2. Now for here, we're going to be using our conversions of r squared equals x squared plus y squared, because r is the hypotenuse, and then tangent theta is y over x, because we have our x and our y, and we want to convert it over to r and theta. The radius is usually pretty easy to find. I don't usually put the negative sign in with the radius just in case you forget to use parentheses. So that comes out to 2. Our radius is going to be square root of 2. Now we do have to be careful with quadrant 2 because we end up getting here tangent theta equals 1 over negative 1. Now we have 2 options for our quadrants. So it's all students take calculus. Well, what that means is I can either get an answer in quadrant 2 or quadrant 4 for it to be negative. So you almost kind of want to solve it like your equation unit, but we only want the answer in quadrant 2. So your reference angle for this is 45 degrees. And I could also put that in radians, but I'm gonna, I'll do both. I'll stick with degrees for right now. So 45 degrees. And then we want our answer in quadrant 2. So our answer in quadrant 2 would be 135. And then reference angle pi over 4. So that would be 3 pi over 4 for that. And our final result would be radius of root 2, angle measurement 3 pi over 4. Now there are other options for this. For example, you could do negative root 2 because we know we want it to be in that second quadrant, and then we're going backwards into that quadrant. So negative root 2, negative pi over 4, go back to Q2 is basically what that's kind of showing. The next one's a little easier. So the next one would actually be a positive x, negative y. That's going to be in quadrant 4. So I would put a star next to the first one. Your quadrant 2 points are going to be the trickiest because the quadrant 4 is what the calculator would give you. So once again, we're going to do our radius squared, 4 squared plus 4 squared, 3 squared. Notice I didn't put the negative in with that. For this, we get that equal to 8. Now 8 does break down into 2 root 2. So you do want to make sure you always simplify your radicals here. And then tangent theta is equal to negative 4 root 3 over 4, which is negative root 3. Now you have a couple options for quadrant 4. If you plug that in the calculator is going to give you negative 60 or negative pi over 3. And that's definitely a usable answer. So you could put 2 root 2 negative pi over 3 because that does end up in quadrant 4. Another option for your quadrant 4 would be to do 5 pi over 3, which would be your 300. So your quadrant 4 could also be 300 or 5 pi over 3. I wouldn't probably go with a negative radius on this because it's falling in quadrant 4. It's when it falls in quadrant 2 that you might want to do this situation, or if it falls in quadrant 3 when it's positive. So it's when it falls in the quadrant where it's not that principal value quadrant like we had talked about in the equations unit, that's when you have to be careful. So quadrant 2, oops, sorry about that. Quadrant 2 is not a principal value quadrant. Hence why that case is going to be a little trickier for these. And then you can always check with graphing that you end up in the right spot. So if you did root 2, which is like 1 point something, 4-ish, and then 3 pi over 4, that would end you in that quadrant. Oops. For 0.1. And then if you were to graph 2 root 2 and then go in the negative direction, you're somewhere down here. Well, not somewhere, like right around here. All right, so also just checking that at the end would definitely be helpful. All right, so now if you watch these in class, you're ready to do your practice. If you watch them for homework, then you're going to be doing practice in your next class period.